Welcome to the online lectures for software engineering. In today's class, we'll be studying architectural patterns. In the previous class, we have studied about architecture styles. Within these styles, we have studied the few styles, architecture styles that were data-centered architecture, data flow architecture, call and return architecture, object-oriented architecture, and the last one is layered architecture. So these are the 5 different styles that we have studied. In today's class, we'll be studying about patterns, and I'll give an example for what is the difference between the architectural style and the architectural pattern. Now, what is an architectural pattern? An architectural pattern, it can be defined as a reusable solution. It is defined as a reusable solution to a commonly occurring problem. That is, if suppose a problem is occurring every time, what is the solution that you're going to do? Like if suppose your Wi-Fi isn't working, you're on your phone and you see that your Wi-Fi is not connected. What are you going to do? Will be your first step? You're going to check whether your Wi-Fi is being plugged in or not. You're going to check whether all the lights are there, whether the connection is there or not. Then you're going to go for the troubleshooting. So this is a commonly occurring problem. For that, you've got a reusable solution. The same thing occurs within the architecture whenever you're designing a particular software. So this is a reusable solution for a commonly occurring problem within your software architecture. Now these architectural patterns, they are going to give you an approach for identifying some of the behavioral characteristics of the system. That is what is the behavior of the system? Sorry. It's the behavioral characteristics of the system. Now a few architectural patterns that is defined by Bosch with a person named Bosch. Uh, 3 architectural patterns are there: concurrency, persistence, and distribution. So in styles, we have studied 5 different patterns, 5 different styles are there. And in patterns, we're studying there are 3 different styles that were defined by the person named Bosch. Now, if we take an example for what is a pattern and what is a style, we take an example of a style. A style can be like how you're going to design a building, or how is a door going to be built, or the window. These are the example of your styles. What type of door you're taking, what type of windows you're selecting, how is the building going to look like. These are your different architectural styles. Whereas when you come to patterns, if we take an example for patterns, it is going to tell you, if suppose you want to redesign your room, so within this room you're going to have different patterns. You're going to have where the sleeping area is going to be, where the study area is going to be, where is going to, all these patterns are defined. So you're going to have different patterns. Like you can have a kitchen pattern. Placement of different applications can be there within a kitchen, within a kitchen pattern, where the appliances need to be there, where the stoves need to be there, where the cabinets need to be there, where is going to be the countertop, the lighting, everything. So this is an example of styles and patterns. Now coming on to the different architectural patterns, the first one defined here is concurrency. Now one approach is here, first we'll define concurrency. Concurrency means applications must handle multiple tasks in a manner that stimulate parallelism. That is, when you want to execute different applications parallel, you're executing one specific application, one is being running, you also want to run another application together, that is application 2, or you can have another one also, that can be an application 3. So these are the how you want different applications to be working. You can be downloading a picture, you can be making a presentation, you might be listening to songs. So these are the different applications that are running in parallel. So that is your first type of architectural pattern, that is your concurrency. Now, here you're going to have two different approaches for achieving the concurrency. One approach is to use an operating system, process management system pattern that is going to have this operating system process management pattern is going to have all the features that are built within the operating system. Now, this operating system is going to allow all the different components to execute parallelly. Components to execute concurrently. So all these features are embedded within the operating system itself. Whereas the next one is your task scheduler. Now this task scheduler pattern, this is another approach that is defined by this task scheduler. Now this is going to be executed at the application level. At the application level, this executes. Now whether this task scheduler is going to contain, now this task scheduler, this is going to contain a set of different active objects. Now these different active objects, these active objects, each of them, now there's not going to be one object, they are going to be different active objects, like different applications are running. What are different active applications? These are your active applications. Now these active applications, these all are going to have a tick operation. This is going to have a tick operation. Now the scheduler, this task scheduler, this task scheduler is going to periodically invoke this tick operation for the next concurrent object. Now suppose this is going to have one tick operation, one is the other application is having another tick operation, another one has another tick operation. So this scheduler is going to pick the tick operation that is concurrent to the object, that is the one that is running. So this is going to pick this is going to pick another application concurrent object. So these are two ways in which concurrency can be achieved. The next type is persistence pattern. Now what is persistence? Data persists if it survives past the execution of process that created it. That is, whenever, if suppose whenever you're executing some specific data, if after executing that particular program that data is still remaining, then that is called as your persistent data. That is, that particular data is not going to completely vanish away, or it is not going to delete even after you're executing it. That is going to be stored. Now this persistent data, this is normally stored within databases. It is stored in database, or it can also be stored in a file. And these are used to either read the data or modify. Now, whenever you're accessing data from either of them, either the database or file, this data can be used to read or modify the data at some other time, not that at that particular instance, but can be modified at any instance. Now, whenever you're using these object-oriented environments within software engineering for developing the software, so these object-oriented patterns, they've extended this concept of persistence, where your data is just going to persist after the execution. They've extended this concept within the object-oriented environment. Now, within this object-oriented environment, what this is going to do is all the different value of the different attributes or the different state levels, whether it is active, the state of object, and other supplementary information, all of these information, it is actually stored for any future reference or future retrieval of data, or either for using them. This is going to it is going to store the data. Now there are two patterns that are commonly used. The first one is the database management system, and the second is application level persistence. Now within the database management system pattern, this is going to apply all the storage and retrieval capabilities that you've studied within DBMS. You've or how you're storing the data, how you're going to retrieve the data, all of this is going to follow this very same approach that is used within DBMS. Whereas the next one is the application level persistence. Now, this application level persistence, now as here within the previous one, you're just using the same features of DBMS. Whereas within this application level features, what is going to happen is that these patterns are built within the application itself. The application is directly going to store the data within the system. So that is application level persistence. The next type of architecture is distribution. This distribution, the manner in which system or components within the system communicate with one another in a distributive environment, is called as distribution. Now, distribution means distribution like distributing the data. Now, if suppose one task is completed by one component and that data needs to be accessed by some other component for completing some another task. So that is called as your, so this is how you want the data to be distributed. So when these different components are going to communicate by the either accessing data or for message passing, that is called as your distribution. Now this distribution problem, it addresses the manners in which the systems, it addresses two different problems. There are two elements within the problem. Elements, the first one is the way in which entities connect to one another. That is, in order to perform communication, your entities first, they need to be connected. So the first problem that arises with the distribution is how the different components or how the different entities within the system, how they are connected to one another. The second way is the nature of communication. That is going to occur between the different components or the different elements. So these are your two elements that are considered as a problem for distribution. So how one component, this is another component. How these two components are connected and what is the nature of communication, how they're going to communicate, whether that is going to be done by message passing or either by using shared memory. Now, the two techniques here that can be used for communication. Now, shared memory, it is like where all of your data are going to be stored within a file that will be accessed by the different components. That is one way of communication. Or message passing means you're going to request some specific data from the application by sending a message, and the another person is going to reply you with that particular data. So that is how you can communicate between the different applications. Now, there's one common pattern that is used within the distribution. That pattern is called as your broker pattern. This is the most common pattern. Now, this broker pattern, it acts as a middleman between the client component and the server component. So if we take one as client and the another one as server. So the client sends a message to the broker. As the broker is going to be there, there is going to be a broker in between. So the client is going to send the message to the broker, and this is going to complete the connection. So broker is then going to forward the data to the server. So this is how the broker the broker distribution pattern is going to work. Like, you're going to have a middleman in between that is going to establish the connection, or whenever you want to disconnect the connection, you're going to make contact with the broker. Now, one example for distribution is the Corba. This is an example for the broker distribution pattern. So this is the end of architectural patterns. We've studied architecture styles and architecture patterns. Now these two answers are important. Architectural styles, it can either ask the entire styles and patterns answer, or it can ask as 5 marks each of them. So this is important answer. Architecture styles is the most important answer, whereas pattern is also important, but styles is more important. It was asked more than these patterns. Thank you.